we've learned how to count the total number of functions you can possibly have between two finite sets. But what if we want to narrow our scope? What if we want to find how many one-to-one functions can you have between two finite sets? Well, what logic are we going to be using here? Well, let's remind ourselves what the definition of one-to-one is. One-to-one means that for all elements in our domain A, if the codomain is equal, then the domain elements must have also been equal. So this means that if you had your A and you had your B, and you have two arrows going into your element here in B, it means they must have come from the same element in A. It cannot be that the second arrow came from a different element in A. This would not be one-to-one. So let's say you have these two sets, A and B. What do we find? Well, let's draw them out. This would be way easier to see if we draw them out. We have 1, 2, 3, and we have 1, 2, 3. So let's take the first element, A. How many possible ways can we map our first element? Well, 1 can go to 1, 2, or 3. It can go to any one of these. Let's say 1 goes to 2. Okay, let me actually redraw the 1 down here. Okay, fantastic. So 1 went to 2. Okay, where can our 2 go? Well, because for it to be one-to-one, we cannot have 2 go to the same codomain as 1. It means that 2 can no longer go to 1. 2 can only go to 2 or 3. So 2 has 2 options. 2 has 1 or 3. We'll let 2 go to 3. And this means that 3 cannot go to 2, because then we would have A is not equal to 3, but this would be equal, so it would not be one-to-one. And similarly, 3 cannot go to 3. So this means the only option 3 has is 1. So what did we find? We found that 1 has 3 ways, 2 has 2 ways, and 3 has 1 way. Now, what does this mean? This means the total number of ways is going to equal to 3 times 2 times 1, which is going to be 6. There's 6 total possible one-to-one functions we can have here. Now, of course, you can switch this around and say, well, what if I want to map my 2 first? Well, then 2 is going to have 3. And if you want to map your 1 second, 1 is going to have 2 ways. The order of which you do this still does not matter, but the next choice is going to have 1 less choice. And what we find here is that it's going to equal to 3 factorial. What if we increase our domain by 1? So now our domain is bigger than our codomain. How many one-to-one functions can you have? Well, let's think about this critically, right? Let's draw our sets once again, B and A. And let's draw our elements, 1, 2, 3, and 4, and then 1, 2, and 3. So how many possible ways can we map 1? Well, we can map 1 3 ways. We can map it here, for example. How many ways can we map 2? Well, we can't map 2 to 1 anymore, otherwise it wouldn't be one-to-one. So this means that 2 can only map to the ones that haven't been mapped to already, 2 or 3. So 2 can map twice. So 1 can be mapped 3 ways. Then 2 can be mapped 2 ways. What do we find? Well, then 3 can only be mapped 1 way because we have only 1 element remaining. So 3 can be mapped 1 way. But then what do we find? We find 4 can't be mapped to anything, because if we map 4 to 3, then it wouldn't be one-to-one, because even though 3 you can get 3 from 2 and 4, 2 is not equal to 4. They're not the same element. So it wouldn't be one-to-one. Similarly, you can't map 4 to 2 and you can't map 4 to 1. So you can't map 4 at all. So what does this mean? Well, this means that you can't leave it like this. You can't leave 4 empty, because then it wouldn't be a function. In a function, you have to map everything in your domain. And here, for it to be one-to-one, we can't map our last element. So what do we find? We find that in conclusion, if the size of A is greater than B, then there are no one-to-one functions. You just simply can't make them, right? By our reasoning here. So if A is bigger than B, then 0, 1-to-1 functions. Okay, let's have a look at one more example. So now I've increased B and made A smaller than B. So we know we're not going to follow that rule. Let's go ahead and think about this. How many possible ways can we map the first element to something in B? The answer is, well, hang on. 1, 2, 3, 4. Okay, when mapping the first element, how many options do we have? We have 4 options, right? We can map it to something like this. So we have 1 has 4 options. Okay, what about 2? Well, 2 can't be mapped to 2 anymore because then it wouldn't be 1-to-1. So we have 1 less option. We have 3 options. It could be 1, 3, or 4. Let's map 2 to 1. So we have 2 has 3 options. Okay, and finally, let's have a look at our last element, 3. 3 has only 2 options. We can't map it to 1 and 2 because then we wouldn't be having a 1-to-1 function. So let's map it to, let's say, 4. So we say, sorry, this is supposed to be a 2. 3 has, oh wait, no, this was correct. 2 has 3 options, 3 has 2 options. So our answer is going to be 4 times 3 times 2, which is going to be 24. So what did we find? Well, let's go ahead and write down everything we found so far. So we're going to say the size of A is going to equal n. What do we find when the 2 sets have the same size? Well, we found that the total number of 1-to-1 functions is going to equal to just n factorial, the size of the function's factorial. So we had 3, so it was 3 factorial, right? Okay. What about if our A is greater than our B? What if our domain is greater than our codomain? Well, then you find the answer is 0 because can't make 1-to-1 functions because you would then have too many functions that don't have enough elements in our codomain, and you'll end up either not having to make a function or having to forfeit it being 1-to-1. So you can't have a 1-to-1 function. But what if our A is less than B? Like we had the example of 1, 2, 3, and then B had 1, 2, 3, 4. Well, we found the answer was 4 times 3 times 2. Now, what did we notice? Well, the size of A was 3, and the size of B was 4. What can we maybe see here? Well, this is actually going to be equal to, this is multiplication, my apologies. We're going to see that it's going to be the size of A, 4 factorial, over the size of 4 minus 3 factorial. It's going to be the size of B divided by the difference in the size of B and A factorial. So this is going to equal to 4 times 3 times 2 times 1 over 4 minus 3 is 1. So that's just going to be 1 factorial. 1 factorial is the same as saying just 1. So this is going to be the 1's cancel, and we get 4 times 3 times 2. So that is how you're going to solve your problems when your codomain is larger than your domain. You're going to say that it's going to equal to m factorial over m minus n factorial, where the size of B is going to be m being the number of elements B has. So this is how we count the total number of 1-to-1 functions between 2 finite sets.